Hello. So we are going to continue with talking about functions. Now, some of this may be review from what you've covered in previous years of Algebra 1 or even some pre-algebra stuff, but there are some important things that I do want to go over and refresh your memory, and maybe even this is something that you were totally confused with in Algebra 1. So we're going to revisit and expand on it a little bit. So, with functions, we have to first define what is a relation. So a relation is a set of ordered pairs. You can kind of think of it like if you think of what is your relationship to like your siblings or something like that, you have some sort of connection between the two. When we're talking about ordered pairs, you have x and y values, right? We also call those inputs and outputs, but we'll get to that a little bit later. Now, in terms of what is an actual function, functions, so here's a definition that we're going to do. A function is a relation in which each input has exactly one output. Now, I use these terms of input and output, but really what they mean, input, that's all of your x values, and your output is all of your y values. So let's look at a couple examples of some different relations, and then we'll examine the function or not. So let's say we make this little table here. So I'm going to talk about days and high temperatures. Let's say here's Monday, Tuesday, Wednesday, Thursday, and Friday. I won't go into the weekend. 72 degrees, here's 85 degrees, 81 degrees, 82 degrees, 81 degrees. All right, we'll come back to that table in a minute here. Next, let's do this guy over here. So I've got one circle, then I've got another circle. This is called a mapping diagram because I'm going to map from one number to another. Our inputs are on the left side, our outputs are on the right. So I'm going to draw an arrow from -3 to 4, and then an arrow from 0 to -5, and then I'll draw an arrow from 1 to 6, and then I'm also going to draw an arrow from 2 to 4. So that's another type of relation. So you've got tables, you got mapping diagrams, and then you can also have like graphs. So let's say here's my graph. I'm going to add a couple points here, so I'll add one here. I'm going to add one here. I'll add one down here. I'm going to add 2 here. And then I'll add like 1 over here. I'll kind of skip a line. Now, these are all relations, right? Every input has an output. If we are thinking of it as, is it a function or not? So each input has exactly one output. Now, if we go to this table here, the day and the high temperature, you can't have multiple high temperatures within a day, right? You could argue, well, what if the temperature got higher than the high temperature? Well, that's the new high. So here, this is a function because each day has its own independent output of a high temperature. So it is a function for this table. Now, for the mapping diagram, there's a couple different ways to determine function or not based on that. One of the easiest ways is actually to turn these into coordinate points. So each one of these lines actually corresponds to a coordinate. So I can turn all of this into a set of coordinate points. I'd have -3, 4. I would have 0, -5, 1, 6, and then 2, 4. And this is actually going to show us a function as well. So yes, this is a function because all of my inputs have exactly one output, right? I can follow. I know from -3, it's going to bring me to 4. From 0, it brings me to -5. From 1, it brings me to 6. And 2, it brings me to 4. Now, this graph over here, if we are examining this, we could say, well, there's a couple ways that I know of that I could figure out if this is a function or not with this relation. So what I'm actually going to do here is I'm going to turn each one of these dots into its corresponding coordinate point. So I've got the first one is 0, 4. The second one is 1, 1. The third one is 2, -1. And then I've got 2 dots there at 3, 2, and 3, 3. Then I've got one final one at 5, 0. So there's our relation, all those coordinate points. Now, if you kind of picked up on it, I hesitated a little bit, so I might have given this away. But notice here, the box feature didn't work. There's 2 3s, and they both have a different output, right? I've got a 3 and a 2 and a 3 and a 3. So because the one input of 3 has multiple outputs, that's what makes this not a function. So if we go back to our definition of functions, a relation in which each input has exactly one output value, you really are thinking here that for it to be a function or not, your x values cannot repeat. So make sure you make that note. I even put a little stars around it. So the x values cannot repeat if we're talking about functions. A relation doesn't always have to be a function, but in our case here, we want to specifically examine what is a function and what is not. Now, in terms of graphs, there's another way to determine if something is a function or not. And a lot of you may remember this from Algebra 1. It is called the vertical line test. In the vertical line test, the technical definition, if a vertical line passes through more than one point on the graph, of a relation then the relation is not a function. If the vertical line passes through more than one point then it is not a function. We can examine this last one here. If I was to draw vertical lines going straight up and down here at all of my points, notice here, my vertical line passed through two different points. So that's what made it not a function. I'll give you a couple more examples of these types of graphs. So I'll make this neater. And I'm going to cheat a little bit. I'll copy and paste. I'll add like a dot there, 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 and there. So with this relation, again, you can draw vertical lines, and it's only going to pass through each point once. I'll do another relation here. Tighten this up a little bit. Let's say I add this parabola, remember that term. If I add some vertical lines, notice it's touching my parabola only once each time. Even though this is like gonna go up and up and up, it never becomes vertical, so this is a function. So this first one was a function. This second one was a function. And this third one here that I'll draw, let's say I give you this. So I drew a circle. It is a relation, however, it's not a function. Look, I only added one vertical line, and right away I could see that it passes through my graph twice. If it passes through twice at any point, it fails and it is no longer a function. So not a function. Now, one final, or actually there's a couple more things, but as we are talking about functions, a few other things that we have to define are domain and range. So your domain is the set of x values, and your range is the set of y values. So we're looking at a bunch of x and y's. Let's use, I'm going to make up two examples here. So let's say I give you these coordinates. I've got -3, 2, 6, 1, 1, 2, 3, 0. Now this is called a finite set because I know exactly how many points I have in this relation here, right? I know that there's 4 different coordinate points. I could also have a relation that looks like this, where I've got a point and then an arrow coming off of it. This would be defined as an infinite set because there's an endless amount of numbers here for my domain and range, but we'll cover those a little bit later. We'll go back to the finite set just for this time being. So if I'm listing the set of my x values for my domain here in this example, and so you're just going to list out your x values in order from least to greatest and without repeating anything. Now you're just listing the x values. You're not like turning them into coordinates or anything. And because it's a set, you're going to use these little brackets. So you can practice those. They're kind of fun to like get into the swooshiness. So I want to order these So list in order from least to greatest, and then don't repeat. So as I look at my lowest x value, I've got a -3 there. Then I've got a 1. Then I have a 3. And then a 6. So that's my domain. It's -3, 1, 3, and 6. Now my range, I'm going to do the same thing here. So we're listing it as a set with the little squiggly marks. So our range is all of our y values here. I've got 2, 1, 2, and 0. So it starts with 0 and then 1. And notice how there's 2 2's here, but I'm only going to list it once because I just want that one number. I know that 2 is in my range. I don't care how many times it's within my relation there. So domain and range, you're just listing your x and y values in a set there. And then the final thing that we're going to talk about today is function notation. So with function notation, it's just a different way to represent functions. Now, in the past, I could have given you an equation like y is equal to 3x minus 4 and told you I want you to find y when x is -1, let's say. And you're like, cool. So I know that I'm going to plug in this -1 for the x. So I get y is equal to 3 times -1 minus 4. So you're like, well, y is going to be -7. Now this is a relation, right? -1 is your input and -7 is your output. So I know, I know I have the coordinate point of -1, -7. But in algebra, when we're using function notations, we're not always referring to things as y, because if I'm trying to compare multiple different functions, I'm going to say, okay, so this y graph or this y graph or this y relation or that y relation. So instead, we use function notation. So you might have seen this in the past. You've definitely seen this, where I might call this f of x. So I name the function with the letter. So it could be f of x, it could be g of x, it could be h of x. I can use a ton of different letters, right? There's 26 different letters that I could use to name my function. And I can use that same equation, and these two things mean the same thing. Now, the x, that's what your input is. So I could also phrase this question in a way where I say evaluate f of -1. And that's all the instruction that I give you. So I give you f of x is equal to 3x minus 4, and I say evaluate f of -1. Well, what I'm doing is I'm taking this -1 and I'm plugging it in for the x. So f of -1 is equal to 3 times -1 minus 4. So then you're like, well, that's -3 minus 4. So f of -1 is equal to -7. This is your answer, which also corresponds to this coordinate point, right? This is your input, and here's your output. And what we defined earlier is that your input's your x and your output's your y. So function notation is just a different way of representing these relations, but we're able to name them and analyze them a little bit differently. All right, so copy down these notes into your notebook and then get started on your homework.